In this video, I'm going to show you how to delineate nested surface depressions and catchments, and also simulate inundation using the LiDAR Python package and the toolbox within Arcgis Pro. Okay, so first let's go to GitHub to download the toolbox. So go to the GSWQS/LiDAR. So the URL I also put in the description below. And so once you're on the website, click post and download as a zip file. So if you know how to use Git, you can also use Git clone to download the repository. So I'm going to just click download and then hit save. Okay, so it's has been downloaded to my downloads folder, and all I need just right click and extract the file. So you'll be let me just extract here. So you'll be creating a new folder here under here. And so in this video we're going to use the toolbox. So it's under the LiDAR and toolbox. So we have two versions in here. We're going to use this one, Arcgis Pro, and because of the ArcMap, the first one is for ArcMap, and due to the limitation of Python 2.7, some of the packages that this toolbox needs can no longer be installed using Arcgis 2.7. So we're going to use Arcgis Pro. So it has the newer version of Arcgis 3 or Python 3.x. So we can use the full functionality of the toolbox. So once you have downloaded the toolbox, next we can open Arcgis Pro. So you need to install that using Arcgis Pro, and so we are going to click here, right click, make sure you open as run as administrator, because we need to create a Python environment. If you just click, it won't work. So make sure you run as administrator. Once it's open, then you can create a new map, and we can create a new Python environment. So if you want, you can click here settings, and from the settings, Python. And then it's gonna take some time to refresh the environment. Okay, so once it's here, click the manage environments. And if you haven't cloned this before, you might only have this one. So by default, it's Arcgis Pro -py3. So that's the default one. And you need to click the clone default. Once you hit the clone, you will generate a new one just like this. Okay, so it might take 10-15 minutes actually to clone the entire environment. So please be patient. Once it's done, click OK. Then come to here, add package. Okay, so add package. From here you can search scikit, scikit -image. Because I already installed, so it doesn't show up on the list. I can come back to here, install, and if you scroll down, you will see that I already installed the scikit image, because this one is for image processing. So it's a very powerful package, and so the LiDAR Python toolbox relies on this one. So make sure that you come here to install the package. You just need to search and then on the list and then click install. It should be installed to this environment that we're going to use. Once it's being installed, then we can click here new, and you can create a new map. So I'm going to create a new map, and you can choose a new name for your project. So in this case, I may just call it LiDAR. Okay, whatever name you want to use, then click OK. Once the map is created, then we can add some data. Okay, so because we already downloaded the toolbox to the C downloads folder, then what we need to do is go to catalog, and from here, folders, just right click, add folder connection, and then navigate to C under your user and the name. Then you should be able to find the downloads folder. So we're just going to go to the downloads, and we can connect to this one, LiDAR master. Hit OK. So it has been connected. And next, we're going to load a sample data set. You go to the examples in LiDAR DEM and select this one, DEM_full.tif. So drag this one to the map and then just hit yes. You should have this DEM loaded to the map. And so if you uncheck this one, this is DEM in the state of Minnesota. So if we want to visualize, we might want to create a shaded relief. So what you can do is go to the tab imagery and then click raster functions. On the right here, you will see this one, and you scroll down to the bottom surface, then click shaded relief, and from here select the DM that we use, DM full, and then just create a new layer. Okay, so now it's much better. So you should be able to see this, the DM here. This is the one that we're going to use. And so let's open the toolbox. So go to LiDAR and then toolbox. So make sure you use this one, Arcgis Pro Hydrology Analyst. Okay, and then here we have the 7 tools we're going to use. So we're going to go through one by one. And the first one is extract sink, because this is a DM, right? You see a lot of depression. So the first step is actually to extract the largest inundation extent, and then later we can go deeper to extract the nested hierarchy. So we're just going to click this one and then select the input DM. So it's not the shaded relief. Make sure you select the DM full. You can also use your own data, okay? And then you can change the settings. So minimum sink size 1000 means 1000 pixels. So this is DM 1 meter resolution. So 1000 pixels, it's basically 1000 square meter. If you want a larger one, you change this to a larger number or smaller one. So basically what we are doing here is that if the depression smaller than 1000, we want to eliminate those. So we just want to fill the DM. So at the end, we keep the larger depressions, remove the smaller one, because smaller one might be just artifacts of the DM data. So, and then you can also use a sink depth. So if it is shallower than 1 meter, we want to treat it as artifacts. So again, keep larger one and deeper one, and then we remove smaller one. So you can click here, save. You can save this one to whatever you want to save. Like we can, the folder here is under the project LiDAR. So we're going to create a new folder, and then maybe choose the name output. Okay, click. So the first one here is to create a sink. So we can just type sink. It will create a shape file and just hit one. It might take a couple seconds, so you can view the detail and then click message to see when the program is running. So a couple of steps this one is doing. And so once it is over, you should be able to see the shape file, the polygon representing the depressions. Okay, so we have the results now. And besides the sink polygon, we also have 3 data layers. Okay, so let me uncheck the sink. This is the sink, basically a subset of the DM. And let me uncheck all the others so that you can see clearly, right? So this is the sink, basically is the depression. And the smaller one already been removed. So this is the a subset of the DM. We also have the so-called DM partially filled. Let me uncheck the other. So partially filled, that means smaller depression. Basically, it fills smaller one and then keep the larger one. We also have the DM fully filled. So this one is basically all the depression have been fully filled, has been fully inundated. Again, if you want, you can go to image and raster functions, and we can create a shaded relief. You can see the difference between the original one and the fully filled depression. Okay, so this is the fully filled. Right now, you see these are all right now become flat because it has been filled with water. So we can compare this one with the one beneath. You should be able to see the difference, right? So you have water have been fully filled, and this is actually the depression that has been filled with water. We can double click, maybe no color, okay, and we can also change the color to something else, maybe let's say black color, right? So now you should see clearly we have the depression now, and we also have the DM that has been reprocessed. So the next step is to delineate catchment. Once you click, you should see the partially filled DM, right? So this is the output from the first step. And then again, sink polygon. So click folder. This one will be the catchment. So we can just type to the name, maybe catchment. Hit enter, run. And you can view details of message. So to take a look at when this is running. So what we are doing in this step here is to delineate the catchment. So the catchment means the water area contributing to that depression. Okay, so it has been finished. Then we can maybe click here again. We can change to no color and maybe change the outline to blue color or something else. So double click and color properties. Maybe change to this one, the dash. Okay. Or maybe what else we want to use? Maybe this one. No, very good. Okay, how about this? Or maybe change to black color anyway. So a little bit thicker. Or we can change to maybe blue color, might be slightly better. Or we can put this one somewhere. Let me see here. How about yellow color? Okay, yellow color looks better. So this is basically the catchment. So the catchment contribute water to this depression. The black one represent the depression. So the yellow one represent the watershed. So watershed contribute water to the depression. And let's move on to the next one. Delineate flow path. So we can just based on the input. This is the free field DM, and the sink polygon is the one from the first step. The rainfall intensity, this one right now doesn't matter, so you can just keep it as default. We're going to use that later, so it won't change the results. So what we want, you can just type flow path, hit save, and then run. So again, it might take a couple minutes to delineate the flow path. So what does that mean is that when a depression is fully inundated, the water is going to flow somewhere to the downstream. And so what we want here is to figure out the flow network. So once every depression is inundated, we want to know where the water is going. So from the upstream to the downstream. So in that way, we have the flow path. As you can see from here, right now we have these lines in here. So this shows the connection between the depression. So it might be from here to here, next one to next one. So if you want, you can double click and maybe scroll down, see if we can have something like an arrow. So for example, this one. So now you see that we have added an arrow to here. So if this one is fully inundated, water is going to flow down here, down here. Similarly, you might see some other locations. For example, in let's say this one, right? It's actually from here, from this one to this one to this one. Yeah. So you can visualize the changes of the water, the flow path. Okay. So next step, let's delineate the hierarchy, because so far we have only delineated the catchment and also the depressions, but there's a hierarchy between within those depressions. For example, this is the bigger one, but within that bigger one, we have a lot of a smaller one inside. So if I uncheck the shaded relief for the fully field DM, you will see in here, right? Within this, you see a smaller one. So what we want here is to click the tool, input the DM, the sink. So the sink here is basically the polygon, the raster that I showed you earlier. It's this one, okay, this DM. So what we want is to select the sink teeth. You can adjust the parameters, so the minimum depression size and also the depth and also the slicing interval. You can keep this as default. So this is the algorithm using the label set algorithm to delineate the hierarchy. And so all we need is just the output. I can just choose to label.tif and then hit run. Again, you can open the view details and can take a look what the algorithm is doing. Okay, it's over. So the output has been it's not automatically added to the map. We can just load it manually. So go to the folder LiDAR and then output. So you will see this one label.if. That means the hierarchy. So you might see it from here from 1 to 5, right? So some of those it is just one big depressions, but others might have a hierarchy. So with the water increase, some of the smaller ones going to connect together to form a larger depression. So you can clearly see here over this one on top of let me uncheck the sink in here. If you see this one, right, it has a hierarchy. So you know, for example, this depression and this depression, with the water level increase, they are going to merge into a large one, and this one merge into a large one. So at the end, it's going to be fully inundated, and then the water is going to flow to the downstream. Okay, so once we have the can go back to the toolbox here. Once we have the depression hierarchy, we also want the catchment hierarchy, right? So anywhere that you have a depression, you want to have a catchment area. So basically the watershed. Earlier we did in this yellow one is the entire catchment to this big depression, but within the small one, you can also have the catchment hierarchy. So we want to again use the partially filled DM and the depression hierarchy shapefile. So that one is actually from here. You go back to the output folder, you will see this one shape, right? Single label 1, 2, 3, 4, 5. You can add those to the map if you want, but I'm just going to simply input that one. So here, partially filled DM, and then the depression hierarchy. It's this one. Is it okay? Then we can output the catchment hierarchy. So the hierarchy is going to be a raster files. So we can create a new folder, maybe call the new folder catchment, catchment, okay, and then just hit open. Oh, you need to let me just maybe create a CSM catchment. So it's going to be a raster file, and once we have that, we can just click. Maybe we don't need to put the one within the output folder. We can just put it directly in here, catchment. So it will a GeoTIFF file. Wait, let me come back, go to here. We don't need this folder. Let me delete the folder. So under the here user, where is this? 1 second. Because later we're going to create a catchment hierarchy. So right now we don't need this one. So I'm just going to delete this one here. We need to probably refresh. It's gone. Then we can come back to the toolbox. Delineate catchment hierarchy, and then input the partially filled DM, also the depression hierarchy SHP, and the catchment hierarchy. So this one right now we just need the output. We can type catchment, okay, and hit run. Read the details, see the process. And if you see from the depression hierarchy, because we have 5 depression hierarchies, similarly we're going to generate the catchment also 5 hierarchies. So we have 5 files. We're going to have generate 5 catchment hierarchy, and after that we can continue to the next step. So else. The next step is to simulate inundation. Okay, so it's done. Then we can just click number 6, input sync image. Okay, sync.tif catchment hierarchy image. So this is the one that we did just delineated. Okay, it's not automatically add to the map. We can add that one to the map. So I'm here, refresh. It should be the catchment.tif. Is it here? Strange, it's not coming up. Did we save to correct location? Let me take a look. So delineate catchment hierarchy. Hide output catchment.tif. Okay, so it seems because the earlier we already have name catchment.shp, so it might not there might be something wrong with the file name. So we can maybe just run this 2 again. We can change to catchment hierarchy, catchment underscore HIR whatever, and then hit run again. Let's generate the new catchment. So hopefully it will work this time. And let me open the V details. Click this one. Web files. Oh, okay, it's within here actually. It has been generated. So catchment 1, 2, 3, 4, 5. The folder is called swap files, and so let's just wait for this one to finish. Okay, it's done. Then we can move on to the last step to simulate the number 6 to simulate the inundation. So what we need, input the sink DM, and then the catchment hierarchy image. Again, then let me come back to here. Let's refresh. Here. Okay, so it seems Arcgis is not Arcgis Pro is not working properly earlier. So I just close and reopen. Now you see this catchment.tif is showing up here. And so this is the catchment hierarchy. Let's go back to the toolbox under LiDAR master and LiDAR toolbox. Arcgis Pro Hydrology Analyst toolbox. Then we can move into the next step, simulate inundation, and input the sink image, also the catchment hierarchy image. Right, so this is the second one. You can change the settings for others, but I'm going to keep it as default. Again, the minimum depression size is how big is the depression you want to treat as a real one. And if it is smaller than this one, 1000 pixel, it's going to be treated as artifact. It's going to be a fill. And slice interval, rainfall intensity, how much rainfall, 5 centimeter per hour. And we are going to simulate for 50 hours. The time step is 1 hour, so every step is 1 hour. And we just need to output the inundation folder. So we can create a new folder called inundation. And just select, hit OK. So let's run. Open to see the details. So basically, it will be 50 iterations. It's going to run 50. We are simulating 50 hours, so 1 hour, one iteration. And I'm going to pause the video and come back once it's finished. Okay, so the inundation simulation has been completed. Then we can move forward to the last step to play the inundation. So just double click and then we can select the input DM. This one we're going to use the partially filled DM. You can also use the original one. It won't be too much difference. So we can select this one. And then the loops, basically how many times we want to see the simulation. So we're going to use 3 loops. What we need to do here is to select the inundation folder, click OK, and then hit run. It's open a new window, and this is where we're going to see the inundation. So it's going to from 1 hour to 50 hours. So you will see the water level is increasing right within this depression. So when it's increasing, you should be able to see some of the depression. When enough water is going to connect into a larger depression complex, and once it's finished 50 hours, it's going to also go through the decreasing process. So basically wetting and drying. So this is the drying process. When the depression is fully filled with water, and when it becomes drier, water level decrease, and you can see those larger depression being split into small one, right? So again, this is the last simulation, water level increasing. You will see again depression merged together into larger one, and once is fully filled, water is going to flow to the downstream. So this one basically simulate the inundation process, how the water level is increasing and how the landscape is changing depends on the water level. So you can if you want to see more times, you can also change the rainfall intensity. You can also change the duration of the inundation. So and to play as many times as you want. And this is just a simple demo. You can apply to your own data to simulate inundation. Depends on rainfall intensity and also depends on the region of your interest. And okay, so that's all for this video. I hope you enjoyed this video. If you have any question, you can post the question on GitHub. Take care. Bye bye.